expert in this field. He'll be guiding us for this incredible 3 days bootcamp. And and I'm also excited to announce that this bootcamp is a collaborative effort with Gir House, Saranda House, and Vayanand House. This is a this brings us together with the mind of sharing enthusiasm for technology from all around our community. So big thank to everyone from each house for your support and commitment. Today marks day one of our 3 days bootcamp of our microcontroller coding. Over the next few days, we'll explore the fundamentals of microcontroller, dive into coding, and gain hands-on skills for this 3 days bootcamp. Without further ado, let's get started. Please join me in welcoming Mr. Levin Nectar sir to lead us into fascinating world for our microcontroller coding. Over to you, sir.
Yeah, thank you, Kritika. Am I audible?
Yeah, you're audible, sir.
Okay. So, good evening, everyone. So,
Good evening, sir.
yeah.
Good evening, sir.
So,
Good evening, sir.
I hope you will have heard about this workshop and what it is going to be. It's a hands-on workshop on microcontroller program. Right. So, what we are going to discuss in this 3-day workshop. So, the basic idea of this plan of this 3-day workshop that I'm having in my mind is in the first day, I will introduce you to different terminologies, terms, and tools. Uh, so the different things that you might want to look into before starting this programming thing. And in the and you will be doing some of these exercises. I don't want to keep it like you do this set of exercises to do it because I didn't feel it's. I feel that it's a too much of constraint to uh, actually get things to practice, right? So you actually want to try out the things that you need or you like. So I don't want to do that. So in the second day, I'll be doing some programming and discussing some programming best practices. So today I'll be discussing the concepts, and tomorrow I'll be discussing the best practices that you need to follow during programming and project management, right? And day after tomorrow, hopefully, I am planning instead of me doing something, it's better if some of you among you form groups and do some projects, and it can be a project presentation and review. Like, so we want multiple people to show what they have done in this workshop, right? From what we have learned, we want to build a simple or some complex thing that can be demonstrated in this. Okay. Uh, is my idea clear?
Yes, sir. Absolutely.
Okay. So then with that, I'll start with the presentation. I hope my screen is visible.
Yes, sir, it's visible.
Okay. So let's start from the basics. So we are talking about microcontrollers, right? So we have to talk about what microcontrollers are, and you may also have heard this term called MPUs and how it is different from microcontrollers, right? That's the first thing that we are going to see. So the basic difference is in a MCU, everything is in a single chip, and it's simple. And in a MPU, it is much of a. It's only a processor, and you don't have all the memory and the peripheral associated in a single chip, right? It's not like. So that's what the main difference between MPU and MCU. The microcontrollers that you see in these embedded systems or the IoT devices that you see are actually MCUs, and MPUs are used in high performance computing process, like a smartphone or a simple device that you want, like a computing device. Okay. And with the MCUs, what are the different MCUs that are available that we have, right? So as you can see, there is Arduino STM32 boards. So these are different boards. If you want to see it quickly, so Arduino has this Uno board, which is very popular among this, which looks like that and things like that. And here you have this documentation. So if you want to know anything, everything about this actual board, Arduino Uno, this version R3, which is very popular among everyone, you can find it here in this official website. So, so there are differences between what a development board and a microcontroller unit is, right? So this thing, Arduino, this is a development board, right? So it has a USB, and this is the chip, the internal uh, processor or the control unit that controls everything. So this chip is called Atmega 328P chip, right? And it actually has these pinouts which are connected to these pins which are used for development, right? And the thing is, you can actually remove this chip, and so once you program it, you can actually run it without the whole setup with the breadboard. Okay, so for example, you will have, I think so. Oops. Yeah. So there are ways in which you upload the program to the chip, and you can run the chip without the separately in a separate micro, right? And this is how you. So there are tutorials in the Arduino website itself, by using which you can create a Arduino board separately on this. So what is a development board and what is a microcontroller unit? So that also one thing we want to differentiate between. It's a small detail that maybe people miss to differentiate. And there are this Arduino and STM32 ESP. These are different manufacturers. They develop these boards and the chips that are there. So the common differences between these four popular MCU boards or the development boards is Arduino boards are easy to deal with. They are simple enough and used for simple projects and hobbies. And the STM boards are used in professional applications. They are actually made of this ARM processor. Right? The core of this is ARM processor, so they are used in professional and industrial applications. This ESP32 board actually comes with a Wi-Fi module built in. So these boards are a popular choice for building IoT applications that actually communicate with. So Arduino boards are mostly used in the robotics or control applications, whereas the ESP boards are mostly used in IoT applications. And the Raspberry Pi board, it's as you have seen, it's a like uh, the Raspberry Pi can actually run a simple OS in it, visual OS. So it's a kind of big thing. And you also have various communication things like USB and HDMI, other types of input built into that board. So it can actually work like a simple computer in that sense. Okay. Yeah, Akash.
Sir, what is the meaning of IoT?
So IoT is Internet of Things. Uh, so have you heard these things about the smart fridges that actually tell you about whether you can activate the fridge from long, and smart air conditioners which can be activated from outside, smart water heaters. These things are actually connected to your home Wi-Fi. So they make a internet like a network of things that can be controlled. The signals from them can be sent to a server and controlled over internet. So That thing is called IoT, Internet of Things. Okay.
So they make a database of the items themselves to connect communicate between each other, like that.
Basically, they are connected in a network. So if you have learned about the computer networks, these boards can be like usually in a network, your devices like mobile phones and laptops will be connected, right? They can form a network through internet. What about machines communicate with each other and the servers? So then that forms Internet of Things rather than Internet of devices that we use. Right.
Okay, like a network. Yeah.
Yeah. So they can interact with each other, or also we can control with our devices that are connected to the internet. Pretty much like that. Controlling and data sharing between the things. So these smart home appliances are the best examples for the IoT. Then about development boards, as we have seen, this so each of these people provide create a a microcontroller unit, and they provide a development board to with some circuitry around the board, so that we can easily develop systems with that, right? So this is ESP. So this board, you can see it, right? So there are different development boards there, ESP32. Different models are also there. A popular one, just Node MCU. So, like Arduino, this Node MCU board is a very popular ESP32 board. It comes with the Wi-Fi module built in, right? This thing. Similarly, you have STM Nucleo boards, which will be like this, right? I hope I can show you these things. So, this is a website called Walkme, where you can actually simulate this microcontroller boards. See, there are different versions, different models of ESP32 development boards are present here. Right, from the simple one to the complex ones, the different versions are there. And similarly, for Arduino, you have a tiny board. This is just this chip, a tiny chip, and Arduino Mega, Nano, and something. And so, it's like a collaboration between two things, Arduino and some other framework kind of board that is a other development board. So most of the popular different development boards are supported in Walktree, right? So you don't have to worry about that. So, and Raspberry, you have Raspberry Pico boards that are present here. So Raspberry Pi is actually a bigger board than this. Yeah.
So I have a question. Like we are doing it right now on Walkme. Are
Yeah.
there any other simulators? I have heard about Proteus because sometimes I see, maybe I'm not able to find it, but some actuators or sensors are lack in this Walkme software. Is it?
Yeah, not all the sensors and things are present here. So you can see, so in the supported hardware section, you can see which are the boards that are supported and what are the, so see, these are the different uh, components that are supported here in Walkie.
Okay, sir.
So, and also in some of these boards, some features are not available. For example, if you see in this, yeah. So here in this diagram reference page of Walkie, you have reference about every component in that are present in Walkie. Let's find ST Nucleo. Yeah, this is ST Nucleo board, right? In this component, you can see the list of features that are implemented here. So timers are actually not implemented in STM. but the other features like I2C, SPI, ADC, watt, GPIO. So the basic things are actually implemented over.
Okay, sir. So one more question: what is the best simulation software for currently?
So as far as I have searched, what is kind of easiest and it has more drag and drop elements to start with. So for beginners, I'm not sure. Still, I'm not sure about the advanced simulators. For beginners, like you want to work with projects that involve simple minimal components, you can go with Workey. And also there is this thing in Workey, you have this Gypsy API to define your custom chips actually. If you want to define a custom component, you can actually create yourself. So you have to go through a lot of reference to do that. So using this API, you can actually create a custom component. So assume you are trying to simulate some kind of sensor that have some pins, right? Then you can actually define that pin over here using this chip APIs. How that pin, like that sensor or a component will behave. You might not have a visual photo for that, but you can actually include this kind of peripherals using these different APIs for your simulation, right? So in that way, I feel Walkbee is currently the kind of uh, best thing about in the simulators. But it is not offline. But you have an offline version with a paid subscription. But I don't think that would. It's kind of costly. But the free version works well. But it is online. That's
Okay, sir.
okay. So you can actually, if you want to create a new sensor or a component, maybe not boards, but the sensors or components can be easily created with this chips API. You can actually program on how that chip will behave. That's what this is about.
Sir, can you please once again tell about the components of the microcontroller?
Okay, so basically a microcontroller unit is just this chip, right? This thing. This what you see here is a development board, right? So it has some circuitry so that we can actually, so you have see this USB port over here, right? So that we can uh, try out, like we can easily like uh, try
Connected with
out,
the device.
yeah, run program here. You can upload programs again and again and test your program. You can make connections to the peripherals with this board and check how that works. So these kind of things, right? So so that are the, so usually there are boards, these development boards without any USB thing also there. So those are minimal boards. So it depends on the need, what you need actually. Simplicity, ease, performance, memory, the number of pins, those kind of things. What your application needs, you should buy a MCU board for that. Okay, so that's why we have this large varieties of development boards from. Uh, okay, let's see here. Yeah, the different
So the
boards.
components changes as we want the need. It depends on the need, what kind of board we need.
Yeah, yeah. So if you,
Okay, sir.
like assume you are taking a very big board and your application only need very one or two pins, then is that really necessary? Assume your application don't need a Wi-Fi module, so then taking this is not necessary, right? So each board comes with different components. So that we have to. It's like you have different varieties of boards that comes with different components. You can see, right? This is a low power, cost effective with Wi-Fi and Bluetooth module, right? The main thing is the microcontroller unit, and those are peripherals and built-in modules that are present. Right.
Okay, sir.
You see, this is a very simple board with STM. So what's our need? You can take a board for that. So for people who try out different things, usually this Arduino Uno board is very popular among. If you don't know anything about what to buy the board, people will buy this Arduino board. And if you want to try out professional embedded system development, you can buy STM boards. So there are this STM Nucleo variants, and there is Discovery boards. There are also different types of boards actually present in STM. That you have to explore, and you have to check about what are the different things that it has. So that's why we have this reference. Each board will have a pinout diagram, which means it will, if you see what are the pins that are available and what are the functionalities that pin can handle. So that will be described here, right? So there are these different pins that you see here. And similarly, for a STM board, yeah, this is a STM Nucleo board manual that you can find there, and it has what are the things that are there in this board, the pinout diagrams, and what are the features that it board has. It has a USB thing and things like that, right? So you see some kind of very complex configurations at first, but once you begin to deep dive and read these things, get used to it, then you will understand most of these terms actually, right? So this just specify what are the things that this board has. It has 2 push buttons, it has 3 or 4 LEDs, and it supports these protocols and things like that, right? And also this board has Arduino connectors, which means this is actually, this board that you see here is compatible with the Arduino board, which means, so there are some software hardware shields which we call, like they are additional devices that can be put on top of an Arduino board. So to provide support for that kind of devices, this STM Nucleo boards, or some of these boards are also supporting this Arduino pins. So things like that are also there. You can see this is compatible with Arduino Uno, this board. So the things that you do using Arduino Uno can be also done with Nucleo boards. Right. And you can see what are the pin numbers, which pin has which are the functionalities, and all the details in this manual. So each of this will have their manual. You can go to the official website and see, find these manuals. These are the data sheets that you want to refer to before selecting it. For beginners, we select just any board and just go with it. Just we don't care about what are the functionalities we need, right? So you can try out in any board and every board, unless that supports what you are trying to do. So there are these programmers that we have for Arduino. So you see this development board set. It comes with all these peripherals and things. And there are also some devices called programmers, which can be directly used with this thing. So you see here. So here they are making a Uno board, and this is what the programmer is. So actually, this thing is a programmer. Right. So there are these different boards that we can use. Right. Yeah. So this is the AVR programmer adapter, and this is the programmer. Okay. So you can also do things like that. So then after you program this chip, you can actually put this in a actually you can this is a development board, right? You can solder this and actually put it in a for what it have been programmed. You can put it in that device that you are trying to make with this chip, right? Okay, so these are some comparison between different things. So Arduino, is F4, F4 series. So there are different series like F4, G4, and the different boards are there, and you can choose. So there's what are the common things that it has. Right? So this is very big. It's a very professional grade thing that you can see it has all the available things. This is a simple development tool. And how we program this microcontrollers? Actually, we have different programming languages that can be used to program these microcontrollers. So mostly the thing that we use is C, C++. So the Arduino libraries and the Arduino things are usually in C++, which is just an extension of C, as you know, with objects. And C can be also used to develop these microcontrollers. And MicroPython. So this is a specific version of Python that can be used to program these microcontrollers. And also the Circuit Python's kind of Adafruit's version, kind of a fork of that thing. And you have Rust. So you may have heard about Rust. So Rust is a programming language, and people say this is a safety focused strong language. So what the safety here means? So safety here means memory safety. Right. Okay. So in C, when you program with pointers and stuff, what will happen is there are many memory leak issues, memory safety issues, dangling pointers, those kind of things may occur. Uh, you may not reallocate the thing and there's things like that. So Rust is a system level language, but it is modern and it won't have these bugs. So most of that things in C and C++ give rise to errors when the program gets very large and things like that. So there are these race conditions that happen. Race condition means so true process or two functions trying to access the same variable, and it might not properly do the thing. It might override the variable and it may read the variable wrong. These like things can happen. So those are the very detailed stuff. So there are many bugs that rise while in programming with this. To avoid those kind of scenarios, people use Rust, but Rust is not very easy to learn. It's actually has a very steep learning curve that you want to learn. So Python is simple. As you know, it's very easier to learn. You might have also learned Python. So programming with MicroPython is considered one of the easiest, and also this Arduino's C thing. So there are different versions of C programming that we use actually. That is called the programming frameworks. So here I have discussed some of the programming frameworks that we used to build applications. And the Arduino framework is considered the simplest one among the frameworks. As we have seen, there's the setup and loop functions in this Arduino. You select an Arduino project, you can see the setup and loop function. This is the code you run once, and this is the code you run forever. So as simple as that, and you have this very easy convenience functions. Yes. So there are very simple functions and things that you can easily. So these are very higher level functions, right? You can easily use these functions by looking into the function, what the function does. Yeah. ROJ.
Sir, I had one query. What do we mean by UART and SPI that was written in the particular row of the Arduino tab?
Okay, that we are coming to later. We are coming to that. So I'll be discussing that later. Okay.
All right.
There are basically communication protocols. So we'll also discuss about that. So So this Arduino's way of programming is programming in C, right? And there is mostly suitable for this Arduino boards. And there is this STM Hall, which is hardware abstraction layer, which means uh, they provide us it's also a kind of library. So similarly, this Arduino has this kind of functions. Similarly, STM Hall also have those kind of function. So if you see, this is the document that containing. This is a very big document actually. It has very detailed description of different functions. So you see, these are the functions that it has, and you can see very high level thing and things about the compilation process. So this is the manual about programming STM Hall and what are the different files. So STM Hall is written in this header files and this Hall C files, which has some built-in functions to give you control over. So writing programming with your hands in STM Hall is quite different, like difficult in some sense, because the function names uh, are very difficult to learn, and also most of the functions that this Hall has are used for configuration. Configuration in the sense initialization of the peripherals. So in Arduino, you have only functions like pin out, pin mode high. So it's very simple in that. But in Hall, if you see the code, the initialization code will be of multiple lines. So that's why the STM people, they provide a tool called STM QMX. So this tool will generate code based on the visual configurations that you actually configure. So I'll also show some about that.
Sir, is it necessary that we only use Arcri and Arduino board, or we can use any programming language
Sorry, could you repeat?
for modulating it?
Could you repeat?
Sir, is it necessary to use only C language, or we can use any programming language like microprogramming or Rust, etc.?
You can use any programming languages for any boards.
Okay, sir.
At the end, there is a compiled program that is going to be run on that microcontroller, right? So there are different ways
Yes,
of
sir.
programming the same board. And it is not that the STM boards can be only programmed using STM Hall. It can be also programmed using Arduino framework, using the setup and loop functions. So if you want to program this STM boards with Arduino IDE, you have to add some board manager files. So those provide some adaptation layer from this Hall. So actually, they convert Arduino like code to Hall code, those libraries. With that, you can actually program this STM boards with Arduino. So let me show this. Actually, we'll go in order, I think. So where are we? I think we were here. Yeah, the different programming languages. You can actually program in different things. For example, in Walkwe, if you see, you go to new project. So Walkwe also support programming in different languages. Uh, Sourcing project. So here basically you can add any files that you need. If you add a CPP file, so Walkwe has certain things using which it can actually detect which programming language you are using and which framework are you using, things like that. So Walkwe has some capabilities on some generalizability on that. Let's choose this, and you see there are these templates that are there. You can start with Arduino in this Raspberry Pi core, or MicroPython, or CircuitPython. Right. So some templates will be there, and you might want to look at the MicroPython reference. We'll have this documentation, right? So I think there are something given for different uh, boards that they use for ESP board and things like that. I'm not sure about this board, whether this has reference. But the API would be simple, right? And one good thing about Walkbee is you get to learn about this examples, learn with examples. So over here, for each board, if you see, there are some examples that are given here, right? And there is this MicroPython guide. How do you run code in MicroPython? Some sample codes, and also there are community projects that will be displayed over here. If you go to you can see, right, it also supports Rust programming. So how to this are ESP thing program in Rust, that is this RS extension. And there are these projects that are community projects, right? Project done by different people that are posted online. It is also a sharing platform, right? So you can find this thing, see the code, learn from there how they have coded that, and how the connections are there. So that thing's also there. So in that way, using Walkbee can be put in learning new things. You might get project inspirations from that, what you can do here. And there are a whole list of components. And also, when you select a component, and each component will have a reference and also examples using that component. So using that, you can actually learn some things. That. And there are also different JavaScript frameworks. This is one of that. And also there are different frameworks in JavaScript also. Okay, so when should we choose what? So these are the most commonly used embedded system languages. So okay, so you can see this MicroPython thing is also very simple, right? And you can also add libraries in Walkbee. So there is this libraries.txt. This will have the libraries included here, but you don't have to edit this. You can do that using this library manager. You can add libraries from that or upload a zip library. Right, so I think this is not free. Okay. You can actually manually upload that also by copy pasting the libraries. You can create a file, right? A library is set of files, and you can do that manually. So I think that's fine. So if you see here, the Arduino IDE look like this. In an Arduino IDE, you have there is also a library manager with that. And if you search for libraries, you can actually see. So let me search for a library. There's a servo library, and I go here about to more info. Sometimes it goes to the Arduino if it is an Arduino library. Otherwise, it goes to let's see this a GitHub page, and you can see the source code of that library. So there are these two files that are actually the library. And if you want to add this to the Walkie project, just copy this file, create a new file in Walkie and put it there. So I think that is fine. For small projects, you can rely on Walkie to do things. So far, any doubts or questions?
No, sir.
Oh, and development environments. So now we want to develop code, right? So the thing is, for local development, so Walkbee is a simulation platform. You can actually develop in the local IDE and then put it to Walkbee and simulate it, right? And there are also different options where you can. I'll tell about that. Okay, so there this Arduino IDE. What is this Arduino IDE actually? It's a, it's actually Arduino IDE is a set of tools. One is this file editor, library manager, file explorer, and all these things that you see here are actually commands. Some it does some operation, right? So Arduino IDE now actually has command line interface. So what are the things that can be done with the Arduino IDE can be done in command line using this Arduino client. The options that you see over here, right? Sketch, compile, verify, upload, these things. These things are actually available in the Arduino client command line interface also. You can install this and basically uh, do things that you would do in this. And there is this environments like VS Code, right? So see, you can actually you do the same thing that you do in Arduino IDE with the VS Code and Arduino client. I think I have Arduino client installed. See, there are these commands.
Sir, I'm
Sketch,
not
compile.
seeing this video.
Oh, sorry. Oh, I think I'm sharing this window. Okay, I'll stop. Yeah. So see, this is the Arduino IDE, which comes with these tools, right? Basically, the editor, the library manager, and also the these commands that you have, right? This is a visual IDE. The same thing can be also done with professional IDE like VS Code. And there is a program called the Cli, right? I showed you the Cli, and I have installed it here. So you see the commands, compiles, all these things are actually present here as a command line interface. Using help, you can actually run those commands from VS Code also. Right. For simplicity, this would be using Arduino Cli is very simple if you want to do some startup projects with that. And I think for creating a project also, uh, sketch. So this command is used to create new sketches. New a name. I have to give a name. So by reading this thing, the command line itself, I know how to create a new. So let's create something called as test. Now there is this thing created. go here and you see this i.ino file is present over there. You can, so now in this INO file you can actually run the void setup and do things, and Arduino file compile. Uh, Board names and setups are there. So when you compile, you have to compile for the specific microprocessor and things like that. So Arduino Fly, we have to check the boards. So board lists. We have to search. So what are the available boards that are actually there? So you can set it up. This is the name for that. So you can set up a project with that and then actually compile it. So this has some level of complexity which this Arduino IDE hides away from you. Okay. Since this VS Code comes with many extensions that might actually help you configuring a project with this. And the one tutorial that you can follow is there is this VS Code extension for what we is present, which means you can actually see the simulations happening inside the thing itself, right? But for that you have to create a sample project. I think this you need these files to actually run this thing. Okay, there are different examples that you have here: Arduino extension examples, platform IO examples. So we'll see about this also, right? Okay.
Can't we directly search in VS Code to download the ID directly
So sorry.
into VS Code? Sir, I'm saying that can't we just directly search into Virtual Studio Code about the Valkyrie ID?
So Walkme ID is not there. There's just an extension for Walkme. You have this thing like VS Code is the IDE, and you can have this simulation extension for Walkme. But actually, setting up the simulation requires some configuration. So that's what this guide says about, right? So you install it to that, and there is this. You have to get a license from this Walkme. So you have to have a Walkme account, and then after confirming that license, then you have to set up this. Best way to get started is you can select one of these examples and try it out there. Okay.
Yes, sir.
So there are these GitHub repositories which you can download a zip or clone into your system and try running it in mode. So setting up Arduino CLI is one thing, and setting up this thing is other things. So this have all the configuration files if you see. So where the build would be and things like that. So if you, so this is actually I think using Arduino extension. So there is an Arduino extension for USB, but the same thing. So when this in using this Arduino extension, you just click a button in VS Code also it will do. But using CLI also you can compile, and so this walkme.2ml has the address for the build binaries. I have a repo with that, just a minute. Example repo that you can start with. Maybe I'll show that tomorrow. So you can check out these tools, right? So in Arduino IDE, one more good thing is it has examples built in. See, for every basic things, you have an example built in. You can pick an example from here, then try it out in what we like, something like this reading. You can see what the code is about. You can try it and connect it to the copy this and put this in Workly to try out things. So in that way, this Arduino IDE comes with some uh, good getting started samples, right? So this is one of this. And for STM, you have this STMQ IDE. So this also has its own set of text editor, project explorer, and things like that. So it also comes with all these things, building and compilation things for HTML. So when you create a new project, file, new HTML project, then it begins with the board selector. You have to select a board and it will download the necessary things for that. And also you need to have a MyST account to download this firmware packages. So you have to have that account and log in here. Right. So this is the target selector. Right. So here we select the board that we are going to use. So the boards that are present in Walkly is this. This board is present. So you can choose this board. This is the one that is present in Walkly. So I'm selecting this and project list. Now it will. I'm loading it with the default configurations. So now you will have this configuration window that opens up. So this configuration window is what is called this MX, Cube MX. Okay. This view can be also separately installed as a separate tool, Cube MX, which will also support this kind of UI view. So the board that I selected, this is the pinouts from the actual chip. I don't have the whole board here because you know which pin is connected to which peripheral in that board, right? That you see from the data sheet. And you can configure the things here. If you want to set up the timer, you can go here, set up the timers. So this is a very simple timer with very minimal configuration. So you can activate that and do things with that. And you see these are this. So there are some pins with that functionalities that's capable of SPI, I2C, UART that you can configure here. So whatever you configure and if you save it, it will create actually. Let's go change this configuration. Okay, I'm activating this, and you can set up this timer settings over here. And when I save this, it will ask for do you want to generate code. I think I'll always generate code when I save. And you see just like how Arduino comes with the setup and this thing loop. Now with setup, you can see there are some code that does this initialization and processing. You can see the time TIM17 and the GPIO initializations have been done automatically. And there is a function called hall in it, and there are different things over here, right? Which is about how we program here in this system. I hope So in this manual, you can see how you can set up this Arduino Cube IDE. All those things, and there are different sections in this hall generated code. You can see these comments like this here: user code, begin a section name in this hall code. I think the font color is not so good. That see this one, user code begin 0. So those are the different section where you will be writing your code, and those sections have meaning. If you see here in this, there is a while loop actually. So the while loop comes here in here. Right. So this begin while user code begin while section is basically similar to your Arduino's loop. And there are different setup that you can do. One in the main function, if you want global configurations, global variables that you can do in these sections, private user code, some function definitions, and things like that. So you can put the function definitions here, private variables here in this within this. So why is that necessary? Is because if we are using MX code, what happens is it when you change a configuration, this codes outside of this comments gets overrated. So that's why you need the sections to write hall code with the STM, right? So whatever code is outside of this comments will be overwritten if you change this .ioc. So this .ioc file is actually kind of text file, but this opens that using uh, a visual configuration tool. But this is actually a simple text file that has the configurations in it. Okay. Open with text. You see, it's basically a text file having different configuration setup. But this IDE provides us this visual thing to set it up. But the visual that thing is called CubeMX, which is also separately available as a separate thing. Here in this IDE, it is integrated inside, but the QMX is also available outside. You can use that to configure this. And here is the main file that you need to write, and these are the C++ files where the all code is present. So these are the definitions of this all code and those functions. And these are the definitions for this. Yeah. Yeah.
Sir, what kind of functions do we have to make for like the microcontrollers, the type of functions microcontrollers do?
What type of functions means I didn't get it.
Means what are they targeting microcontrollers? So like if we are writing a code, what is the code doing? For example, if you're connecting a peripheral and
Okay,
now we have
okay,
written
okay,
something
okay,
in it,
okay, okay,
whatever, for example,
okay. We'll go there also. So this is about the tools that we are using, right? So it's good to check out these tools. So let's go and see how we are going to program these things. So I have to talk about one more thing that is there. This platform IO. Uh, so platform IO comes as an extension for VS Code. You can install it here, and you can create projects within that. And also there is a command line utility that is there for platform IO. See there is a board explorer. So thing about platform IO is that it's up. So as you can see, this Arduino IDE is only supported for this Arduino framework, right? And the STM Cube IDE is only supported for this STM Hall based development. But Platform IO actually integrates everything together. This tool has support for multiple different boards. So this has actually support for different boards and frameworks. So Arduino framework, you know, right? The setup and loop kind of functions that you have, and the STM cube framework, and other frameworks are also supported using this platform IO. Right? And also it supports different boards. So people use this for unified project management. So some code can be run in multiple boards, right? So you can develop the same source code using for multiple boards using platform. You have various support for different different uh, vendors and different softwares. So that's the advantage about platform IO. It's kind of a unified development platform. So now we'll talk about what the code we write will do to the microcontrollers. So basically there are two types of code where starting with Arduino. One is the setup and second the loop. Let's start with the Arduino terminologies. Uh, a simple project. Let's just take a new project. So basically you have the setup and loop functions, right? So what the setup code will do is declare the things or configure the peripherals and things. So configuration code will be present in the setup loop, and the thing that you want to run again and again will be there in this loop function. So let's start with the basic uh, hello world of embedded programming is blinking an LED. So I am connecting this positive pin to the pin 13 and the negative pin to the ground. Basically, these are the two pins. So these are digital pins. So the pins present here in Arduino are digital pins, which means these are digital GPIO pins in their base functionalities, which can be uh, controlled as either input, configured as an input pin or an output pin. So there are different configurations in that, and also each pin in GPIO can be set to high or low, which means on or off. Okay. So now we can set that pin. So we want to configure this pin 13, right? So that's what we use pin mode 13 as output, and that's our setup. And what we want to do again and again. So now, so the LED blink program is to blink the LED in 1 second interval, on off. So you have a function called delay in Arduino, which will make the program wait for certain amount of milliseconds. So 1000 milliseconds is a second. Now, how do we turn on and off the LED? You have functions like digital write, which will write a value to that particular pin 13 high, which means turning on. Now, after 1 second, so which means this line turns on the LED. Then I wait for 1 second. Then I turn off the LED low. Then I again wait for 1 second before turning on. So now what will happen is when this program is compiled and pushed into this, when it starts up, when it starts up, it starts with this thing. It set up the pin mode configuration, right? So the GPIO protocol that you have is basically turning on and off, general purpose input output. That's what GPIO. You can send control signals by turning on or off this thing. So basically sending control signals. In GPIO, what basically sending control signals. Yeah. Yeah, Arav?
Sir, you had connected one of the pins in 13 and another one in GRD. So is there any specific reason for that, or we can connect the pins anywhere we want?
Or you can connect it anywhere you want. I just connect it with the pin that is nearby to the ground. That's it.
Okay, sir.
So it's nearby to the ground, right? So I just put it there.
Got it.
You can connect it to any pin. So all this pin, as you can see from the Arduino reference, uh, we have that. Yeah. You see, all these pins D0 to D13 can be used as a GPIO pins. These are digital pins, and these pins are analog pins. A0 to A5. These are analog pins. Okay, which means they can read values from analog sensors that have varying voltage level rather than 0 or 1, which means they have an analog to digital converter built in with that. Right? That's the idea.
Okay, sir.
And these pins are digital pins, can be either set to low or high. And some of these pins have additional functionalities also. See, these pins are used for I2C communication, and these pins are used for SPI communications and things like that. And these two pins, TX and RX, are used for serial communication. So there are certain pins that will have also additional functionalities rather than GPIO for communication protocols. Okay, let's go with this one. Let's
So can you please explain the code once again before going forward?
Yeah, sure. So what we're basically saying is so as I said, uh, this is the reset button. Okay, so if you touch this, the Arduino will start from scratch. It will turn off and on. That's what basically, and it starts from the beginning. So this line here sets it's used to say that this pin is going to be output pin, right? So there are certain configurations that we need to do in this for the thing. So there is this output mode, input mode, and input pull-up mode is there. So there are actually kind of one output mode, and there is this input mode, input pull-up, and input pull down. We mostly don't use this input pull down setup, but these are used. So output mode is you set to a pin to output mode when you want to uh, control the output voltage from that pin. So these are used to control devices like send signals like turning on and off LEDs, right? And there is this input mode where we use this input mode to get a reading from a sensor or some a device like that, right? It provides the input voltage based on the value there. So there are these sensors available over here, right? Uh, yeah, input. So these are the input things that you can have: a slide switch, and these are passive devices, right? So let's take a sensor. A simple sensor would be let's take this one. So this is a temperature and humidity sensor, which has this three pins. Right. Uh, this is not a simple one. It has. Let's take a simple. Yeah, this is a very simple input device, right? So it has a voltage supply, ground, and an output. So this output pin will be high based on the activities that you have. So this is a PIR motion sensor. When motion is detected, it will turn, like give an output signal of high. Right. Then we know that motion is detected. Things like that. So assume now we want to turn our code into. Okay, let's do this one first. Yeah. So now this is basically configuration. So once you configure that, then you will be able to control that pin. So you can write it to the pin, write a value. For output pins, you can use this digital write function in Arduino to actually set a particular pin to a particular state. So all these functions that are available here will be there in the Arduino reference. So that right, Arduino reference. You go to Arduino reference, you can see these functions that are here. For digital IO, you have these three functions, right? Pin move, read and write. And if you go to that, you can see what are the arguments that it need, what are the different modes that it have. Okay. And some utility functions, analog IO functions, analog read, write, that are used with analog pins and things. Okay. Uh, so is that first code clear? Basic blink. What are you trying to do?
Yes, sir. Yes, sir. Also, the 13 which I have put, if what if we connected with the these first two, in which it is written ARE and GND.
So this is not what we want. So, yeah, digital pins are from 0 to 13 only. These are not
Yes.
digital pins.
Okay.
Okay. So as you see this board diagram, only D1 0 to 13 are the digital pins. So these pins are analog pins. So each pin have some. There are some other pins which have different functionalities, right? Voltage in support for these things and that. Okay.
Okay, sir.
For digital GPIO, you can use one of these pins, 13 to 0 to 13.
Yes, sir.
So each code will have these pins and what these pins support and things like that. Different pins and what are the supported operations that can be performed with that particular. And you can see the specifications. And you can develop with Arduino Clay, Arduino IDE. This is the very high level circuit schematics of that board. Okay. There is this data sheet also is there. So this data sheet has what are the different peripherals and how it can be applied. A pin diagram. What are the pins and what it can be used for? These are the GPIO pins, right? And there are some other pins which can be used. Okay, so you can get all the info about the particular code with this reference. So Arduino references are kind of easy to read because they are simple. STM references are kind of hard to read because they are complex. And you can also try out the different DSP boards and how different frameworks are there. So this Arduino code that I am writing is only one of the frameworks that we are using to develop things, right? There are different frameworks, different functions, different boards, different uh, what do you say, protocols, right? So the basic protocols are GPIO, UART, SPI, I2C, these protocols. There are also very advanced protocols that are specific to a particular board or a microcontroller that is present. That's also there. So I think before the sensor, we'll just have a input with the push button, right? Now I am going to connect this. Uh, let's come to input mode later. Now My idea is, as you see, this code is fine, right? This is fine, right? How this works? You write high, which means you put an output of 1 to this pin, then wait for 1 second, then set it to low, then wait for 1 second. So that makes the LED pin, right?
Is the second
Yes,
wait
sir.
really necessary? Line 12?
Yeah, because if you don't wait here, once this loop ends, it goes back here, which means once it turns low, without waiting, it turns it back to high, which means you don't see the light LED go off,
It will always
Ah,
turned off.
yeah.
right? Once it goes off, it will again come back to high without any delay, which means you don't notice the thing going off.
On and off. Yeah. It will always be
Right,
turned
right.
on.
Yeah.
Makes sense. Thanks.
Okay. And now we'll go to this. So now our idea is we are going to let's connect this thing. So we will see how the push button is present. So push button has a thing like this. So when you push it, this two ends become joined, which means this L and L will become joined and this become joined. So that's the idea. Right. And let's do that. So I'm going to connect this to some pin. Let's take 12. Then I'm going to connect this to ground. Okay. So now I'll do something and say how this thing works. So we are going to set the pin mode for this push button. I am going to set that to input pull up. I'll tell what the input pull up means. And assume that now for now it just assume that it takes input. So if I press this, okay, some signal will be there. If I release this, some signal will be there. Some state will be present in this 12, and we are going to read that. Okay.
So are you
Let's
trying to make it like when you press this button, the lights, like the LED
yeah
lights up?
yeah.
Okay.
So I am going to read digital read pin
Sir,
12.
here, what is the difference, sir? Pull up and pull down, sir. In this
I'll come
case?
to that. I'll come to that. For now, just assume that we are setting it to input mode, just a simple input. I'll tell what a pull up, pull down, and normal input modes are. Okay. Let's start with this. Assume now we are setting it so that this input from here can be read. Okay. So I'm going to use digital read. So the digital read function will get me the value that is present there. And now I am going to actually put it there. Do you get the idea? So this is what I am going to try. And I'm just putting a delay for improving the simulation speed. This is actually not necessary. You can also put a delay to improve the simulation speed. This is not necessary. So let's run this. Okay. Now it's on. I'm pressing the button and it's off. You see, when I'm not pressing the button, the LED is on. And when I'm pressing the button, the LED is off. Why is that? So that's what this pull-up mode does. So what this pull-up mode does is, so you can see this. This is a passive element here, right? This push button don't have any power source, correct? Now, but
Yes,
we
sir.
want to send a signal here. So we don't have a power source, so we are going to drain the power. So that's the idea, which means setting to pull-up mode configures the internal circuitry to make a high signal, which means by default this 12 pin 12 will be set to high. There will be a voltage there. Okay, as if there the internal voltage from the output. and here this is ground, right? So what happens when you close the circuit? The voltage will drain to ground, and the voltage at pin 12 will become low, right? So when you press this, the voltage at pin 12 becomes low because it is shorted with ground. So input pull-up mode by default configures this pin with the voltage as high, and you will be able to read the voltage present at that. And can you make sense with that? How that works?
Sir, in case of this pull-up button, sir,
Huh.
which two which two leads are short circuited when closing, sir?
This and this will be short circuited, and this will be. So there are two things like uh, this is L. So there are these two rods are there. Assume there are these two rods. Okay. When you push this button, there will be a line connecting these two. Okay. When you push this and this will be joined, and also this and this will be joined. This and this will be joined. Everything will be basically joined. That's the idea.
Excuse me, sir.
Yeah.
What if you change the wire from of the light switch from 13 to 11?
Uh,
Then will the setup work or not?
it may or may not. When we don't set the mode, we don't know what might be the voltage that is present there.
Can you please
It's
try it?
it's okay. And also note that this is a simulator, and real life it may cause damage to your board without setting.
Yeah, sir. That's that's what I'm thinking.
Nothing happens. It means I'm not sure whether the LED burnt or it's zero. It's not predictable.
It could have burst.
Okay, so how does a virtual simulator LED burst?
I'm not sure. I just kind of a joke. It may be it's zero there. I'm not sure. But if you want to make it predictable, like the voltage, you want to set it to a particular. And one more thing, if you put it to input mode instead of pull up, the voltage there would be floating, which means it won't be to the high. So it may have some different behavior that you expect. When you set input to mode to input, is when we are using an active device like this. So when you are going to connect this device, you will be connecting a voltage to that and a ground. And this D will have an active voltage coming out. So during that time, when you have an active voltage coming out, you will set the mode to input instead of input pull up. When you have passive input device which don't have a voltage source, it works by shorting the value, right? And you want to note that. So when I press the button, it went off actually. So if you want to turn on the LED when pressed, what you will do? You want to negate the logic using the NOT operator. So now when I press, it will be on, and when I release, it will be off. So while using pull-up logic, you might want to negate the inputs. Now see, now you can see that this is off, and when you turn it on, it is. Get the idea, right?
So like, now it's doing the opposite. Like there
Yeah.
was not equals to, it was taking all the voltage to itself instead of the light bulb, and now what it is doing, it's supplying the voltage or
No,
something.
actually, this we didn't supply voltage to LED with this button.
Yeah, it is
We
taking the
sub we
voltage.
supplied this to pin 12 is the pin that we supplied voltage or drained. using this.
Yes,
So,
sir.
so I assume you will press this. What will happen? The voltage at pin 12 will be 0, correct?
Hmm.
Now we have programmed our code to read the voltage at pin 12. If it is low, then set pin 13 to high. So the logic of blinking this LED is written in our code, not from the thing. So if the pin 12 becomes low, then turn on the LED. So that's
Okay,
the
it
idea.
is. Yes, sir. Okay, sir.
Okay. So this 12 and 13 don't have any connection, right? It's controlled by this guy.
The chip.
Yeah. And our program that we wrote. So now let's also add this thing of connecting a sensor input. So we need a VCC. Oops. Here. Data. Connect it to pin 11. So now I can set the pin mode to input. One thing we need is now pin 12. And okay, now our idea is so when you run the simulation, uh, you will get controls for this sensor. That just putting this to show you that so you will get this controls. So for this sensor, simulating in motion, so it will just direct a motion or things like that. So if you press this, it will simulate a motion, and this high will be sent over there. So now let's see, instead of taking input from 12, we'll take from 11. Digital read of 11. It again. So now let's simulate motion. So when I click it once, it stays for some time. So how the motion sensor behaves is actually, so there are actual different motion sensors. There will be different ways how it detects, and there can be different configurations of the thing. So these attributes, delay time, inhibit time, retrigger, these attributes are the attributes that can control how the sensor behaves. Okay. Sometimes there in sensors there will be some potentiometers that will helps to adjust these attributes. Okay, there will be a potentiometer which you can turn the size to set these attributes as required for some sensors. You have this delay time, inhibit time. So delay time is number of seconds, output will stay high. By default it is 5. That's why when you simulated motion, the LED was turned on for 5 seconds. And one more thing you will notice is this LED is also connected with this, because internally this internal LED is connected with pin 13. So that's why you can see whenever the 13 goes up, you can see this LED is blinking. Okay, now let me show one more thing. So since this is a simulator, all the attributes about the components are present in a file called diagram.json in what way. So here actually you can modify the attributes. Here we saw that attributes over there, right? Delay time is 5. Now we can maybe change it. Delay time is 2. Uh, as a string. So this format that you see is called JSON format. It will be it's a very popular format for configuration and storing structured information, data serialization. People say, and nowadays modern web development revolves around JSON-based APIs. How different web applications transfer data between them is using this format called JSON. And most of the tools also use JSON to store data as files, configuration things and stuff. So just like that, you can have this configuration done here. Now delay time is 2. Now when I simulate this, you can see delay brings for 2 seconds. Right? So those are the things that you can configure by seeing the attributes that are present here. Inhibit times the number of seconds. Sensor will ignore motion out when returns to low, which means so after turning high and going back to low, it will not turn on high, like it will ignore the motion within this time period. And this is for re-triggering. Disable re-triggering means like when it re-trigger means sending high, like during the delay time it will stay high and things like that. If you set it to 0, it won't, or any motion during the uh, delay time, it won't re-trigger again. Only after the inhib time it will re-trigger. So those kind of things that you can set up. So you got the basic idea of how GPIO works, right? Input output, high and low. Digital GPIO is about that, and you have analog devices. So in digital GPIO, the values are zeros and ones, and in analog, you will have values ranging from certain number of bits. So analog will have many values, right? So you have, instead of 1 bit, your value will be some 8 bits or 16 bits. Huh. So actually, this let's go to the reference. Yeah, data sheet. I think that is one. Let's see the analog pins. Yeah, analog comparators. 6 analog pins. And additional data that we have. That I think that's it. It's there. Let's go to reference and this reference. Log read. Yes. Yeah. Okay. So you can see this analog things that convert that value, the analog value, into a 10-bit digital value. So it has that, right? So the values that you get from the voltage. So the voltage ranges. Here you can see the different boards and their voltage range, and that will be converted to this many number of bits. So these bits correspond to the resolution, which means if there are more number of bits, a little change, you can also actually see the little change in voltage. So assume you have 10 bits, you can range from 0 to 1023, right? So those 5 voltage difference, you can have this many possible values to indicate the voltage. If the resolution is more, this value would be 0 to, for example, for 14 bits, it might be will be what, I think 8,000 something. So the values, there are many number of values to represent the same amount of voltage. So that increases the resolution, right? So that's the idea. So it will convert that analog to digital values. So there are different ADCs that represents how they operate upon. This uses a comparator circuit, like it will compare to the reference voltage and produce your output. Right. Now, if you want an analog device, there are devices like the analog temperature sensor is there, and I think there are some devices which are analog. As potentiometers. These are analog. Potentiometers are analog input devices. So let's take the potentiometer. So now, mm, so is that clear till now? Are you any doubts? I think I'm going too fast. Oh,
No, sir.
okay.
All clear.
So did we forget this slide? Slip. Okay, let's finish the GPIO, I think. Then we will come back to this communication and timers. This we can come to as we go along the code. Okay. So now I have this potentiometer. Okay. Now, okay. So there are, so these analog pins are taking inputs, right? So how can we produce analog outputs? So there are different ways in which we can actually produce analog signals. Some GPIO pins, you see this pins, some of these pins, oops, some of these pins actually have the still symbol over here, right? These pins are actually PWM supported pins, which means it's called pulse width modulation. So there is something called as pulse width modulation. We source it out. Right. So the idea is it will turn on and off the digital pin with different timings, so that it, it will do this faster. But in each cycle, the amount of time that it is turned on and turned off varies. That is how it simulates the voltage. So that's how PWM works. Let's go with this Wikipedia page. Yeah. So there is something called as a duty cycle. So it produces this kind of frequency, turning on and off that GPIO pin faster. So if it is turned on for 25% of the time, you will see the amount of voltage that it has. It will not be as high as this pin is through there, but some kind of 25% of that voltage. So that's how it is. And 50% of the voltage and 70% power. I think it's about the power. I'm not sure about the actual thing about the physics and electronic theories behind that. But the idea is this: it simulates the voltage by turning on and off this GPIO pin at different intervals. More the time it is turned on, higher the voltage is. Less the time is turned on, lower the voltage is. That's the idea. So, do you get an idea of this PWM? So this is used to produce different voltages, like kind of simulate different voltages for the output devices instead of just turning on and off.
Like we're increasing and decreasing the level of voltage
Yeah,
for it.
we want to control the voltage output, right?
Okay.
So a quick example of that, maybe controlling an LED. Let's take another LED. We'll make it green LED. This is our green LED. I'm going to connect it to pin 10 and this to ground. So this green LED is connected to pin 10, right? So now let's see. So in Arduino, things are simple. Like you just have to have this analog read, analog write, and everything works. So you can easily start coding with this. So now what I'm going to do is, and I think you can do this. Arduino IDE. You can take actually the examples from the Arduino IDE itself. So if you see in examples in analog, they have something called fading. So the idea is it fades an LED using PWM. Yeah. So let me copy this, paste this. Let's. So here, as you can see, they have, instead of putting the pin value in every position, they have declared it as a variable over here. What is the advantages of using that? If you want to change that pin, you don't have to change it everywhere in the code. There is only one place where the configuration are there. So this is generally considered a good practice to do this, setting the pin numbers as a variable or CV macros as macros. You can using define hash define. So now here we can just change it to 10 for our code. That's the code is there. So here what the code is doing is basically goes on a inner loop where it reduces this value by 5. So there is this value of 0 to 255. So actually this now produces value between 0 to 255, and we are going to set that value over here, which will emulate that. So delay of every 30 milliseconds. So it is going to fade up from 0 to, we are increasing the value, fade value, like this fade value is actually the voltage that we are going to write there, right? The voltage that we are going to put. So in analog read, as you see, you can get values from 0 to 15. In this PWM, it supports values from 0 to 255, okay, which is a 8-bit value. Okay, let's run this. Now we might see, yeah, it is fading up and going down. You can see that is glowing in and out, right? The brightness. If you want to increase the timing of this fade, increase the delay, or decrease the delay if you want this fade to be shorter. We run this now also. You can see the difference, right? So this is how PWM works for analog outputs. Maybe we'll add a delay of 100 millisecond, delay of 100 millisecond here to actually realize the different semicolon. This is C. I added that delay so that you can actually see the LED go off. Okay. Is this code very hard to understand, or do you want me to explain the code?
So please explain the code and so also which block of code is for which LED. I can't able to understand like
10 is connected to this LED, and all this are for the same LED, because in this program we are only controlling LED 10 LED pin. We are controlling this pin and which is connected to this LED.
so all this block of code it is for the green LED.
Yeah.
So can you please explain it like from the
So
start?
okay. Uh, Before this, mm, analog right of LED pin. What is LED pin? We are defined as a 10, right? Now I'm setting it to 0. So I'm going to increase this to 50, 100, 150, 200, and I'll put the max to 55. I'll add a delay, 1,000, 1,000, let's add 50 milliseconds. Okay. So now what this code will do? Idea? Any idea?
First it will put the frequency to 0, then after 250 milliseconds it will turn it to 50 something and say 50 volts, or then after 250 milliseconds it will turn it to 100 and then it will keep on increasing till
Yeah.
255.
So that is what happening now. I think the change is very small to notice. We will try increasing the.
Yes, this will do the same function as the previous one which you made.
Yeah. So this is turning it on in a direction and then goes back to 0. But
Okay.
here, this loop, what it does, goes increase it in a gradual manner, and this loop here decreases it in a gradual way.
Okay, like this is something complex one and the new one which you have written is like simple.
So let's go from here to there. So now I am repeating most of the things, right? So I'll use a for loop instead of writing it down like this. Int value equal to 0, and I'm going to go till value less than 255 is not equal to 255. So anything less than 255 is fine, because okay, let's have this, and value plus equal to 50, right? So in this loop, now I can put this thing there, right? So instead of using this value, I'll use value. Now this whole block of code got turned to a for loop. This is what basically is here, but with some different values. The increase thing is 5, and the fade value, this goes from 0 to 255, starting from 0. If you remove the comments, maybe it will look simple for you. Let's do that. It's just this, right? Now are you able to get the code?
Yes, sir. Now it's much cleaner. I thought that the comments are also part of the code.
Those are comments actually. That explains how it works.
Okay, sir.
So are you comfortable with C?
Yes, sir, a little bit. Yeah, that's understood a little bit of it.
Okay. So because since we are going with C here, I hope I am assuming that every one of you knows C. Okay. No difference. Those are just variable names that we pick. So here they have picked a variable int paid value. Here I am using int value as the variable name. Those are just variable names. You can pick x, y as anything as variable name. Is that clear, Mikul?
Yes, sir.
So now we see how we simulate analog outputs. And now we can go and so there is also a concept called bouncing with these push buttons, which is quite difficult like to understand, and how to program for that is also needs one separate session to do that. Maybe you can refer to some codes on how bouncing works with some examples if you want to learn about bouncing. Okay. What is bouncing and things like that. You can see this bounce tick mark, which you can configure whether the button bounces or not. So that you can explore on your own. And now we'll come to analog input. So take it around. VCC. Now we need a signal. So this signal, let's use A0 for our analog input. Now this is an active device, right? So since it is connected to voltage, so there will be some voltage coming in. So should we use input pull up or input mode for this pin? So the thing is, actually all these analog pins are by default input pins. So it's it doesn't matter. Only these pins you have to careful about whether it is input or output. Because these analog pins are the input pins over here. If you want to generate analog output, you generate that using PWM pins. These are ADC, right? It converts analog to digital, not digital to analog. So that's the thing. For analog things, you don't have to worry about, but you can also set pin mode to input. It's fine.
Excuse me, sir.
Yes.
Yeah, sir. You can share ground pins, right? I mean, different components can share ground pins. That is what you're doing here, I see.
Yeah.
Okay. Okay. Yeah. So, like, you can connect as many components to a single ground pin as needed. There is no
Ground
such.
ground is always ground. Right? You can connect everything
Right.
to a single ground.
Okay. No, I see on the analog side. I think towards the bottom there are multiple grounds that are given. So I was wondering if there is a special significance of that.
No. Like if you are connecting this in a breadboard, there will be multiple components over different places, right? So it might be convenient for things like that. That's it. Like if you see a
Okay.
ground pin is there, so sometimes you can easily connect to that side.
Even on this side, I mean, there are two ground pins. I was
So
just
it's not
wondering if
like
that
so
there is
if
any
you are
difference.
if you are using a breadboard, there might be a different breadboard there. Like you can connect two breadboards over there, right? So for example, assume you have I think you have breadboard here. Yeah, I take a mini breadboard over here. Now we can connect this to here and connect some component over there, right?
Yeah.
So that kind of use cases it might be useful.
Okay. Okay. Got it.
Like
So this breadboard will act
one
like
more,
like a
one more thing.
ground.
One more thing is you are connecting this to. I am here. I am connecting this directly, right? But actually, physically, if you are using jumper wires, you will be only able
You
to
cannot.
put the one jumper wire there, right?
Correct. Yeah. So it's just one pin will fit into that.
Yeah, basically. So that's why if you are using, like, usually use ground, if you are connecting multiple components, you use the breadboard and connect a ground pin. So if there are many components there, you might want another ground pin for that.
Makes sense. Got it. Thanks.
Sir, if we connect the breadboard to the ground, then the breadboard would act like a ground.
Yeah,
That particular row.
yeah, this
Not all
particular
of
thing.
Okay,
it.
Yeah.
okay, okay.
So breadboard is
Thank you.
like I think this one row or column is connected. I think this is one column is
Yeah. I
connected.
mean,
The
in this
bottom.
orientation, it looks like the column. Yes. So
Yeah.
the column will have the same voltage.
So each column will have same voltage, which means if you connect this here, this will also have a ground. This will be also ground. So that's how it's in breadboards. Outs. This. Now we'll read the value. Okay, now we are going to control this LED's brightness with this things input. Okay, so we are going to read the value from this potentiometer using we'll set more, do one thing, pin mode, LED pin to and this output input. So here we can set int what pin for potentiometer pin, say 0. Instead of doing this, just LED pin. So now we are going to control the LED's brightness with the potentiometer from the input to output. So analog read what? And this will give us a value and analog write LED pin of this value. So one thing you might have noticed is that analog read will give you values between 0 to 1023, right? And this will analog write accepts value from 0 to 255. So it's 8-bit and 10-bit. That's the thing. Since you have different ranges of values, what will happen if you go halfway or some amount of way through this? I think it's 1/4, right? 1/4 of this, you will reach the full of this LED speakers. So that's what happens. Okay, now before doing that, I just want to share with this thing. So there is this USB over here, right? When you connect this to a computer while programming, actually the serial communication. So the serial communication happens with this RX and TX pins, and it can be also done with the serial monitor, that is through this USB. So which means while you are developing, the serial output will be also transferring to your computer through this USB cable. Usually we use that to debug our code. So we want to, so this code is not running in your system, right? When you are programming, it's actually running in that. So if you want to see something from that, like if you want to debug something, you will actually use the serial monitor, which is actually the UART protocol. Serial is actually an API for UART protocol in Arduino. You set the baud rate in this one for that, and you can use serial dot println of some values. Example, now I can put this here, which means it will print that value in this ln means next line, print line, which means after printing this, it will also print the next line character. So let's run this for now. See the value 0, right? Now I am going to turn on mention. I can see this comes to 2 and 4 and till. So the whole voltage can be converted to 0 to 1023, right? So now, what are the values that we can give here? So if I am saving this in a variable, what value, and I am writing that to this, and I'm also printing that to serial so that we can see the output in the serial using the serial monitor. So this is what we call a serial monitor in Arduino. This can be found here, serial monitor, that will pop up this kind of display over there. And there is also something called a serial plotter, which will help us visualize values as charts. So if you go to serial plotter and if you play this, I have it printed in here. What value? The plotter will help us visualize that values, the serial plotter, and 0, right? See the value as charts. It's also available in Arduino IDE, the serial plotter and monitor. So see, it goes to full brightness around here, the LED. But if you want to make that LED's brightness to the full potentiometer thing, we want to do a mapping. So the mapping is like scaling of the inputs and output. So for beginners, Arduino provides a very good convenience function just for that called map. So what this does is it converts one range of values to another range. So that is the idea behind map. So for example, instead of writing what value there, I am having a scale what value equal to, I'm going to map what value. So what value is within what range? It is within, input is within 0 to 1024, right? 23. I'm going to map that range to 0 to 255. So basically you are specifying what is the input range and what is the output range, and it will map the values between this range to that range. That's what map function is. And I can write that scaled value to that LED, which will be within 0 to 255. And I'm also doing one more thing. Print space println value. Right. So see, both are 0 now. See, scaled value will be ranging from 0 to 255, whereas the unscaled value will be that. And also we can visualize this in the plotter. You see, how the scaled value and the actual value looks like, because this is our operating range of the value that we need to put there, right, in the output. So this map function becomes convenient. See how you can control it. Is that clear? Any doubts here?
No, sir.
Okay. So I think it's already time for today. So what I would like you to do when we meet tomorrow is, you can explore these tools that I have said, the IDEs, different IDEs, and what we explore different components, different projects from what we, and these references, these manuals. It might be a good place to start, and you can do some example programs from the Arduino IDE. Like there are different programs right over here. You can try that out in what we, and I think it would be good to go. Like you will get familiarized with the basic things. Then maybe tomorrow we'll talk about the uh, uh, communication protocols and how do we install libraries and working with libraries and stuff like that. Okay. So
Okay,
uh,
sir.
Thank you.
So, what an incredible session. A huge thank to you, sir, for guiding us through the fundamentals of microcontroller coding tonight. Your expertise and the hands on approach have truly brought this subject to life. We are all excited to keep building on what we have learned today. And of course, a big shout to each of you being here. Your energy and engagement made tonight even more meaningful. Remember this is just day one. We are we are also having tomorrow, so make sure to join at 10 p.m. Thank you once again and have a great night. See you tomorrow. Thank you so much, sir.
thank you everyone. Yeah. Pratoti?
Thank you, sir.
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 Guys, if you want to watch the
Thank you, sir.
recording, you can watch in YouTube channel also. It was uploaded in the YouTube channel.
Sir, how to download the ID?
It's,
Arduino ID?
you can download it from the Arduino website. If you are using Windows, you can directly download it from the Arduino website. Just go.
Okay, sir, it is given. Yeah.
Yeah.
Okay, thank you.
So that fluctuating that happened is due to because my mouse pointer got stuck. Like, sorry, uh, the fluctuating from 0 to 1 is happening because you see it, this thing, the way I am controlling this, it goes from 0 to 1. If I that's because my mouse pointer is fluctuating in the control. That's it.
Okay, sir.
Excuse
Thank
me,
you,
sir.
sir.
Yeah, Praturi.
Yeah, a quick question. I'm sorry if it was discussed earlier. What language are we using here? It looks a lot like C. I'm not very
It is
sure of the exact language.
it's actually C++. What happens is this.
Okay,
So usual C++ code will have some include statements and things like that, right?
correct, correct.
So
Yeah.
Arduino is a framework. So in this Arduino framework, we have the setup and loop functions. What
Okay,
actually happens is the Arduino IDE will have some preprocessor directives and compilation.
Mm-hmm.
In the compilation process, it actually turns that into a main.c.
Okay,
It
okay,
compiles, it translates, it preprocesses into a main.c and then compiles it. It's actually a C++ code.
okay. So, for
Sir,
other devices that have these programmable GPIO pins, let's say if I want to do something on my Pi, would the code be similar? Would I be able to use the language here, the same Arduino thing, and would it run on any other programmable GPIO
So
interface?
Arduino framework can be used for other boards also, the STM boards and things, but that requires an
Okay,
additional library. There would be an additional library that translate the like Arduino is an API. You can think it of like that. So you can implement the same API for different boards, right?
Right. Okay.
So there have been implementations on that. So, and the tool platform IO actually unifies all those things. In
Sir,
Arduino, yeah.
sir, I keep getting errors in ESP32 for connecting. I can't upload my code.
So do you have are you talking about an actual board or
Yes, sir.
okay? Actual board things might be complicated. Okay, so we should start from scratch. One thing you can do, Vipul, uh, you can come like that 15 minutes early tomorrow. Maybe I'll also try to join 15 minutes early tomorrow. Maybe there we can discuss that. Today it's already late
Okay,
night.
sir.
We can discuss in between time also. No issues with that.
Yeah.
Yeah.
Thank you, sir. Good night.
Thank you, sir.
Thank you. Thank you. Good night.
Yes, sir. Good night.
Yeah. Thank you everyone for joining.